Okay, so coming up with using the second derivative and using those points was the right way to go. So what I did, here's my process, and here's what I tried and what didn't work, and then what I changed to make it work. So I took the two derivatives, and then I knew the second derivative is equal to 0 at x equals 1, and you mentioned that. So I dropped in 1. I got that equation in terms of a and b. So I'm thinking, okay, I've got two variables here. If I were to repeat the process with y prime, I'm going to end up with three equations. So where I'm going to head for this is a linear system of equations with three variables, so I need to have three equations. So here's my first equation. I know I'm going to have plus 0c, right? That's what that is. And then I took the derivative. I used this first derivative, and I knew there's a critical value at x equals -2, max or min, whatever. It didn't really matter at this point. I just knew it was equal to 0. So I replaced x with the -2, and I came up with that equation. And then I said, well, hey, I know 4 is another critical point, so I just did the same thing. And now I've got a system of three equations with three variables. I'm hoping your pre-calculus teacher had you work with matrices. If not, I got some video. I'll post that too online. What I do is, I mean, you can certainly do it algebraically, but three systems, three unknowns, that's a couple of pages of work. So what I did is I did this, and I'll show you the setup. So I knew my first equation was this, my second equation was this, my third equation was this. So what I did is I did 6, 2, and then 0, because I didn't have any c terms. And then the next equation was 12, -4, and 1. And then the next equation was 48, 8, and 1. And then your variable matrix is ABC, because those are my three variables, right? And that equals my constant matrix, which in this case, they're all equal to 0. So then what I did is I threw this into my calculator. I did, if this is in matrix A and this is in matrix B, if you watch my video, you'll get the theory behind it. Basically, you do the inverse of matrix A times matrix B, and I got singular matrix, which that means the determinant equals 0, which means at least one of these two equations are coincident, meaning they're one's just a multiple of the other. Now, I don't see it. I didn't see where it was. I mean, it's kind of what I mean. It's like if you have a system of equations, it's 1, 1, 1, and then another equation is 2, 2, 2. So 1x squared, or 1x, or 1a plus 1b plus 1c equals some number. In this case, it's 2. And then 2a plus 2b plus 2c equals 0. That would be, or if this were equal to 1, and that would be equal to 2. See how one's just a multiple of the other? They're coincident. They're just, one's just a multiple. They have it's the same variable, same equation. So that meant something was wrong with my thinking. So then I got to thinking, and I said, what the problem might be is these two equations where I use the first derivative. A, B, and C would be the same, and they're both equal to 0. I'm thinking, maybe that's the problem. I don't see, well, this times 2, and maybe C times 2. I don't know. So I'm thinking I need a different equation. And then I realized they gave us the point. They gave us the point that's on the graph, 126. So why can't I just go back and use the original equation? And there's my third equation. And that's not dependent on the derivative like the first derivative. I had 2 using the first derivative. So here's my equation using the first derivative, the function. Here's my equation using the first derivative. Here's my equation using the second derivative. So now those are different equations from different sources. I can probably get an answer, and lo and behold, I did. When I did A inverse times B in my calculator, I got those values, and I said, well, now we got to test it out. So here's what I think the original function was, and here's the first derivative. And I said, well, when's that equal to 0? So I factored out a -3 and it factors, and lo and behold, 4 is a critical value, -2 is a critical value. There is a maximum at -2. There is a minimum at +4. So that works. That satisfies that requirement. And then how about the inflection point at x equals 1? Well, here's the second derivative with my values. I took the derivative of that. And there is a critical value at 1. And there is a concavity change. And f of 1 is 26. Well, I knew it was going to be, but I wanted to check. So there we go. I found A, B, and C to work. And works pretty slick. I encourage you to... I'm not going to ask you this kind of question on an exam, not at least where you've got to use matrices on it. But I encourage you to check that out and learn how to do that. It's a useful tool. It'll be useful in calculus too. That's one reason why I teach that in Calc 1 and pre-calc, because I know they're going to use it in Calc 2.